In a world full of mathematical expressions, there are terms and there are factors. Let's talk about the difference between terms and factors. In mathematical expressions, terms are separated by subtraction or addition, or subtraction. In this expression here, we see three separate terms: x squared, 10x, and 9. Factors are separated by multiplication and division. And in this example, we see 3 is a factor, and so is 5x plus 8. It's a factor that's raised to the 4th power, and we'll talk more about that in a moment. Factors can be a part of terms, and terms can be a part of factors. So essentially what I'd like to talk about is the relationship between those two. So x squared, I can think of that single term as x times x. So x is a factor within that term. Similarly, we can think of 10 times x as 10 times x. So 10 is a factor, and so is x. We could also think of 2 as a factor because 10 splits into 2 times 5, and 5 is a factor. And 9, we could think of that as 3 times 3. So those would be factors of the term 9. So within a term, you can have factors, and within a factor, you can have terms. In this factor here, 5x plus 8, we can think of 5x as a term and 8 as a term. And so terms and factors are really kind of relative to the expression overall. And so if something is separated from something else by addition or subtraction, we can think of those two things as terms. And if things are separated by multiplication or division, we can think of those aspects of as factors. So what's useful, I think, in understanding algebraic operations and how to work with mathematical expressions, you need to understand how terms and factors interact. And part of what that's built on is what they mean. So factors are related to multiplication, terms are related to addition. Multiplication, though, at its heart is, in some ways, it's a summary of addition. If I repeat addition, if I choose some value, I'll call it x. If I add that over and over again, rather than writing that a ton of times, I could write that rather as, well, let's see, I have 1, 2, 3, 4, 5 x's, and so whatever the value of x is, I can think of that as 5 times x. So multiplication kind of summarizes that addition. And for that reason, if I had 2x plus 3x, those two terms can be combined. They're called like terms because this represents x plus x, that represents x plus x plus x, and so they would also represent 5x. So we can, in a sense, we can sort of factor the x out away from those two parts of the expression and think of this as 2 plus 3 times x. And so going in that direction from here to there, we would call this factoring out the x. Going back the other way, if I start with 2 plus 3 times x, I could turn that into 2x plus 3x by distributing. So because of the essential nature of what multiplication and addition represent, we can distribute a multiplication across terms, or we can factor a common factor away from terms. Exponents are a summary of multiplication. I mentioned just a moment ago that x times x, I can write that as x squared. In a similar way, the expression 5x plus 8 to the 4th power means 5x plus 8 times 5x plus 8 4 times. So that exponent of 4, it's really a summary of 5x plus 8 times itself 4 times. Some do's and don'ts when working with factors and terms. Keep in mind that exponents represent repeated factors, or sort of a summary of how many times that factor appears in the expression. And the default is that the exponent is 1. Right? So if nothing's written there, I could add an exponent of 1 next to the 5. And so if those exponents don't match, it would be wrong to write this, something not to do. This would not be the same as 5a plus 10b cubed. Because in this case, the 5 would be multiplied 3 times with itself. So this would be the same as 5 cubed times a plus 10b cubed. Something else to be wary of, another don't. The 3, it doesn't distribute easily, or it doesn't distribute simply to those terms. So it would be wrong to say that this is the same as a cubed plus 2b cubed times 5. Right? Those are not the same as what's above. Something we can do, we can't distribute exponents across terms, but we can distribute exponents across factors. So something that we can do, I could write this as 3y raised to the 5th over x squared raised to the 5th. I can distribute the exponent across division, because division separates factors. And I can distribute the exponent across multiplication. So this is the same as 3 to the 5th times y to the 5th. And so it is important to recognize, one of the reasons why it's important to recognize the difference between terms and factors is because sometimes we're allowed to do something with factors that we aren't allowed to do with terms. With an exponent raised to a power, remember this is x squared, so essentially x, the factor x, appears twice inside the parentheses, but then that whole expression appears 5 times. So we multiplied the exponents. That would be the same as x raised to itself, x multiplied with itself 10 times. Of course, 3 to the 5th is, 3 to the 4th is the same as 9 times 9 is 81. Another 3 would be 243. A don't, kind of a big don't. It's tempting. Fractions are troublesome. We like to try to make them as simple as we can. But it's important to know that we can't cancel these x's. And the reason why, x in the denominator here, this x is a term. That x is a term in the denominator. And we can't cancel it with the x up above. So it would not be true to say this is the same as 1 over 1 plus 8. The x's can't cancel. On the other hand, in the lower fraction, the 4 is a common factor. This is the same as 4 over 4 times c plus 3, because 12 is 4 times 3. And so now I can cancel the 4's and write this in a simpler way as 4 over c plus 3. So when working with a fraction, we can cancel common factors from the numerator and denominator. But we can't cancel common terms. So just because something appears up top and in the denominator, you have to be careful. If it's a term, we can't cancel it. But if there's a common factor, something that's multiplied with everything else up top and multiplied with everything else in the denominator, that's the situation when we can. So I think understanding terms and factors, it really does help develop algebraic skills, and it helps understand the limits to working with algebraic expressions. So I encourage you to kind of think about the difference in the examples here, and I hope you enjoyed the video. Thanks for watching.